Hello students, here in Marisha. Today we are going to learn about next chapter, that is the file and disk management. Let's see the disk management. So disk organization. Let's sometime we have run already programs in C, right? For example, to store the value of variables A and B. If suppose I have written integer A equal to 5 and B equal to 10. Okay, so after the execution, right? After the execution, right? Up to the execution, memory is allocated. Okay, after the termination, what's about the memory? Memory released. Okay, so memory released and that particular value of variables are not stored there. So if suppose we want to save this particular file, then that is called as a file, right? File is stored. If we suppose we want to save this file permanently, then file and secondary storage is used. Okay, so secondary storage means what? Secondary storage, that means hard disk. So today we are going to discuss about the physical structure of hard disk. See, hard disk is used to store the memory permanently. Rather than RAM is store the memory, RAM means temporarily. Okay, if suppose power goes down, then in RAM data lost. Rather than in hard disk, right? Then hard disk save the data permanently if suppose power lost. So it is called as a non-volatile memory. Whenever you are going to discuss about the non-volatile memory, then that is the hard disk. And volatile memory, that is the RAM, random access memory. Okay, so hard disk means what? Hard disk is nothing but the storage that is store the data permanently. See here, we have the hard disk, right? This is about the 3.5 inch hard disk, right? So this is shown like this. You might be see the hard disk, right? One is like this and like this. Okay. On the hard disk, some information might be given, like 80 GB is there, means this hard disk storage capacity, that is the 80 GB. Okay, and 7200 RPM. RPM, that is the rotation per minute. RPM. Suppose here we have to show like 7200, right? We have already seen the 1 TB hard disk, right? So storage might be different in each and every hard disk, but what does it means in the hard disk, right? The structure of the hard disk like this. This is the hard disk internal structure. Let's see what is it in this structure. So see, this is the 3.5 pages, right? In this hard disk we have a number of platters or a number of, we can say, CDs. We are using the CD, VCD for the storage purpose. Okay, so here that is called as a disk. That is called as a disk. Disk is nothing like this. Okay, so this is nothing but your disk. Okay, so yes, so this is called as a CD compact disk, we can say, right? But in the hard disk, these platters are by the magnetic tape. Okay, so these are the platers 1, 2, 3. In almost hard disk, 1 to 8 platers are there. 1 to 8 platers are there. Okay, so this kind of 8 CDs are there. See, here the 1, 2, 3 up to 8. Okay, so here you can see the tracks, right? Let's see. These are the platers and these are the tracks. Okay, and these are the tracks are divided into some unit that is called as a sector. This is called as a sector. Okay, and these are called as tracks. Okay, in between these platers we have the spindle, that is nothing but the motor, we can say. It will goes round and round, round and round, round and round. That's it. Okay, so exactly the definition of, we have to see exactly the definition of track, sector and sector. Let's see about the track and sector. So track is nothing but the concentric circle or flat rings on plater that will be tracks like this. Okay, on this surface data will be stored. Data will be stored in particular form of binary, that is nothing but the 0 or 1. Okay, so binary data that will be stored on the surface, and on this surface that may be thousands of tracks are there. Okay, so this is about the track. Now let's see the sector. So sector is nothing but the collection of, see, tracks are divided into the some units. Okay, so that is called as a sector. See, this is the number of sectors are there. This is 1, 2, 3. Number of sectors are there, right? And particular one sector that may be 512 bytes. 512 bytes. So yes, we can say the tracks are divided into unit that is called as sector. Okay, so this is about the sector. Okay, so again the sectors, that is the tracks are divided into some units that is called as a sector. There is a number of sectors are there, and particular one sector size may be 512 bytes. Okay, so this is about the sectors. Okay, now sector is the smallest physical unit. Sector is the smallest physical unit. Okay, and this is read and write head. Read and write head. So let's see, this is the tracks, number of tracks are there, and that is divided into the some unit that is called as a sector. And here see, this is called as a spindle. That is the spindle. So it will be moved like this. Okay, whenever the power supply is there, then it will be moved like this. Okay, so here we are discussing about the read and write head. So here the read and write head are there, right? So it's a minor gap between the disk and head. Minor. We can say that is the hair, it's a air, what we can say, that is the air gap. Minor gap is there. Okay, so yes, and it will be read and write from this printer. It will be moved like this and read and write. Sometime we are saying my disk is corrupted. Okay, that means what? This read or write head is there, that will be touch on this surface and it will be moved like this. So data will be lost. So that's why it is called as a corrupt. Okay, so this is nothing but the read and write head. Each and every printer had a read and write head. Okay, so this is about the read and write head, and this is the arm assembly. This is called as the arm assembly, which we hold the read and write head and arm. Okay, so this is the structure of disk organization, and that is called as a physical structure of the hard disk. Okay, let's see. These are the cylinders. Okay, so when, see, this is the printers. Okay, so whenever this is called as a radius. This is called as a radius. Okay, so radius of this printer, right? And number of printers are there. So we can say that is the group of tracks. Group of tracks are there, right? Group of tracks are there with the same radius. That is called as the radius. Okay, so this is called as a cylinder. Okay, so this is called as a cylinder. And yes, each track is in the different printer, right? This track is on the printer number 1. This track is printer number 2, and this track on the printer number 3. Okay, so that is called as a cylinder. Okay, so in the physical structure of hard disk, you have to just remember these terms like track, sector, then read and write head, then arm, then cylinder, then arm assembly, okay, and the rotation, and this is the spindle. Okay, so this is nothing but the parts of the hard disk. Okay, and already we have discussed which are the functions of particular terms, okay, or part of the hard disk. So we will see later how it's actually work. Okay.
I have 2 drives here just to illustrate a couple of form factors that we design. This is an example of a 2.5-inch drive, as we call it, which would be used, for example, in a notebook computer. This is what we call a 3.5-inch form factor. A hard disk drive is so named because the heart of the matter is where the data is stored, which is on these disks, and the data is stored magnetically as ones and zeros or as magnetic bits that are oriented north or south. It is read or written, as we say, by very small transducers on heads. So this little roughly triangular shaped feature can be thought of as the size of a bit. When we write, and this is the write pole, the flux is essentially focused through that pole. The corresponding area on the media below it is magnetized. The head is out flying on a suspension at the end of an arm. This is an arm, which is part of what we call the head stack assembly. The arms move back and forth across the stroke and read the various tracks that are laid out on the disc. These tracks are so narrow that we fit about 300,000 of them in an inch of radius. The arms, the HSA pivot is actuated in this case, and I think this is kind of fun, magnetically. As we know, electricity and magnetism exist together, and when a current is run through a wire, there is a corresponding orthogonal magnetic field. So how we are using that here is that there is a coil, it's actually hidden under this magnet. Under this plate there's a magnet. And below the magnet is a coil. The driving force of the current, or conversely the magnetism, forces the back end of the coil to move in one direction or the other. Right here we see the motor that spins the media. When the drive is powered off, the heads are resting on this ramp. The arm swings off so that the heads are preserved and they're not touching the media or anything. If I want to write or I want to read, in other words, if I want to record a picture or if I want to bring out a picture file, the arms swing out over the disc and the heads are flying over the tracks, as we call them. So it goes to a very specific radius and the drive will be given an address to go. Let's pretend that was the radius, that was the track that contains the picture or part of the picture. That is the file that we said, please show me this picture. The data is recorded in magnetic domains that are very small surface area on the disc. The transducer on the head senses for that domain the direction of the magnetism and whether it is a 1 or a 0, and that's a bit. The head takes all of those bits and transmits that electrically up into the channel. It is reconstructed back into a data form that we recognize as an image. What we are looking at right now is the surface on the recording head that's facing the media surface. So the disc is spinning under the head, and there's an airflow or shear between this air-bearing surface and the media surface. These darker areas are in relief outward, and the medium range is actually inward. And these surfaces in relief are functioning in the way that we would think of wings or the features on a jet that control the flow of air. Everything that we can see in this view is only to support what we call the transducer out at what is the trailing edge of the head, and it's where the magnetic flux is read and written, or where we control the flux back and forth between the head and the disc. This is a very close view of the transducer, and at the top, it's not necessarily possible to see here, but we'll show a picture in a minute, is what we call the right pole. It's a very tiny dot in the middle of a triangle at that location, and that's where the pole that writes is visible. Down in the middle of this stripe is what we call the read element, and that is the location where the magnetic signal is sensed for the read function. So our magnification right now is 85,000, and our micron bar is 200 nanometers. When you think about it and you think about the size of molecules, we realize that some of these layers that we're looking at are roughly a few atoms or a few molecules thick. That is particularly true of the read element, and it's just a tiny dot or sliver when we look at it, even at 100,000x, and it has several layers which again are atoms thick at most. Very simple in concept and an amazing amount of technology.